All right, we're going to talk about friction right now. So the first thing you need to know is that we call friction, we give it, or rather we represent it with a script F, which is basically like an S with a line through it. And this means friction. The other thing you need to know about friction is that it's equal to the coefficient of friction, mu, times the normal force. So if you're not given it, this is how you would have to calculate it. So friction is equal to the coefficient of friction mu, which is again the coefficient of friction, and most of the time they're going to give this to you, but occasionally they'll ask you to calculate it. So mu is equal to the coefficient of friction times the normal force. Alright, so there's two types of friction. The first is static. Okay, and in static friction, here's the deal. In static friction, we're just going to put a subscript S. Whoops. We're going to put a subscript S down. And what this is the minimum force needed to move the object. Because if the force you're applying, if the force that you're applying is greater than the friction force of kinetic, it will move, or the static friction, it will move. If the force you're applying is less than the force of friction, there will be no movement. And remember that whenever you're pushing something, right, you can push with, say, 30 newtons, and the friction will resist with 30 newtons. But that doesn't necessarily mean that that's the max static friction, because the static friction only resists with however much you're pushing, because the friction can't act. It can't move the object. So it can only resist with however much you're pushing. So it is possible to have a static friction max of like 50 newtons, but if you're only pushing with 30 newtons, it only pushes with 30 newtons to counteract you. Okay, so that's static friction. Next we have kinetic friction. Kinetic friction is just same thing. It's just the motion, whereas static is the motion or the friction from being stationary. Kinetic is the friction of movement. And it's the same thing, we just give it a K underneath, so it's the same formula, we just put a subscript K. And it looks like this: force of kinetic friction equals mu K times the normal force, or the normal force. Okay, so this is kinetic friction. Some important notes about kinetic friction. It always, and just friction in general, it always resists movement. So whichever way the object is prone to move, friction will act in the opposite direction. So let me give you a couple of examples of this. If I am pushing a block against a wall, and which way do you think the friction force will act? Well, the force of gravity is going to want to pull it down this way. So its natural movement would be to go downward. So which way does friction act? Friction acts up. Okay? To counteract the force of gravity, to counteract movement. Alright? There's another option. What if we are pushing something on a table, and we have a force this way? Which way would the friction act? Well, it would act in the opposite direction. In the same vein as this, there is a very, very common problem that looks like this, where you have two blocks suspended with a pulley system somewhere that you set it in motion, and you say that there is a friction force being applied to this block and the force of gravity being applied to this block. All right, let's just give these things some masses. Always a good thing if you don't have the mass and you just can't work it out without the masses. Just plug in 3 kilograms and 3 kilograms, okay? So if these are the two masses, how would you solve this problem? Well, frictional force here will be equal to the normal force on this guy. So if you don't know how to find the normal force, refer to my video. The normal force in this case will just be the force of gravity because there's no movement in the y direction. So the force of friction here will be whatever mu is times 3 times 10. And the force of gravity here will be 3 times 10. All right, that's not really that important, but it gives you a way to solve it. So whenever you do your sum of the forces, and here's where you should pay attention, when you're doing your sum of the forces, it's equal to mass times acceleration. If we're trying to figure out the acceleration of this thing, then when we plug it in, we should get friction resists movement. So I'm always going to plug in friction should always be negative. In this case, though, the force of gravity is helping the movement, so I'm going to leave it as positive. And whenever you solve for this, the mass that you use should be the mass of both of these objects. So it should be 6 in this case. All right, so you would end up with a formula that looks something like that. All right, where the 6 comes from this mass and this mass. Okay, so that's just a word on friction. Hopefully this helps you. If not, then I apologize for wasting 6 minutes and 45 seconds of your time.